Geometry lesson 80. We want to find surface area and volumes of spheres. There is no lateral surface area for a sphere because there's no base on a sphere. So there's nothing to be removed from it until we start looking at things like hemispheres. Okay? So finding a surface area and volume of a sphere. A sphere is a set of points in space that are at a fixed distance from a given point called the center of a sphere. Right? I do have, everybody in here should know what a sphere is. It's a globe or whatever you want to refer to it as. I think I've got a couple of them in here. I can show you some differences between a couple of things. Obviously, don't have video like this, but here's an example of a sphere. Okay, really probably a good example of a sphere that you might see outside of math might be in science. You ever look at in science class where they talk about an electron cloud, right? Where those electrons stay a fixed distance away from the nucleus of an atom, right? That's giving you a pretty good example of a sphere. It's not perfect because some of those are at a different stage or point. They're at different valences and those types of different things. But there should be almost a sphere to it, which means everything on the outside is a fixed distance from the center, okay? All right. And we call that the center of the sphere. So how we identify or how we label the name of the sphere is going to be the name of the center of the sphere. Okay, the same way that we identify or we label the name of a circle by the center of that circle. Does that make sense? Yes, kind of, maybe. All right. So the radius of a sphere is a segment whose endpoints are at the center of the sphere at any point on the sphere. The term radius can also refer to the length of that segment. So we're talking about the line segment that connects the center of the sphere to any point on the outside edge of that sphere. Okay? And so that segment refers to that distance, and that's what we call the radius. Okay? Surface area. So this is the thing that you want to write down, is how do I find the surface area of a sphere? It's a simple formula. It's 4 pi r squared. 4 pi r squared. Okay, I'll give you a chance to write that down. 4 pi r squared. If I ask you what's the surface area of a sphere, you're going to tell me it's 4 pi r squared. Okay? Okay? All right. Then the volume of a sphere, okay, is given by this formula. 4/3 pi r cubed. 4/3 pi r cubed. So those are the two main formulas that you're going to get there that we're going to work with. So what was the surface area of a sphere?
4 pi r squared.
Okay, and the volume of a sphere is?
4/3 pi r cubed.
Okay, you could also probably rewrite this if you wanted to as 4 pi r cubed divided by 3. Okay, it's ultimately the same thing. Okay, does that make sense? All right. All right, leaving us some other things to talk about. A hemisphere is half a sphere. Okay, now this is a hemisphere, right? Can't see it on the video, but I'm holding up a hemisphere. Okay, looks like a little bowl. Okay, so it's half of a sphere. A great circle is a circle on a sphere that divides the sphere into, and that should say 2 as in TWO. Let me fix that. 2 hemispheres. The volume of a hemisphere is half the volume of the sphere with the same radius. So if I wanted to find the volume of a hemisphere, I'm going to take the sphere and I'm going to divide it by 2, which I don't know why they don't give you a formula for, because we can easily figure that out. Okay? How could we figure that out? Well, you're taking 4/3 pi r cubed and you're dividing it by 2, or dividing it by 2 over 1. Okay? Which means we could take 4 pi r cubed over 3 divided by 2 over 1 and end up multiplying by the reciprocal, right? Oh, I'm sorry, this. Okay, so really what we get is 4 pi r cubed divided by 6. Okay, which we can reduce that down, right? What would that reduce to? Should reduce to 2 pi r cubed over 3. Okay, so how do I find the volume of a hemisphere? And again, I don't know why they don't give you that formula, but it's 2 pi r cubed divided by 3. Okay? And that makes sense because half of 4/3 should be 2/3, right? Okay. So you won't find that formula in your book, to my knowledge. I don't know why they don't necessarily list it, but they don't. Okay. All right. Surface area of a hemisphere. Okay. What was the formula for surface area of a sphere? 4 pi r squared, right? So the surface area of a hemisphere is the area of the great circle has to be added to half the surface area of a sphere with the same radius. So the surface area of a hemisphere is actually not just the bowl, but it's the added top on top of it. This is what is referred to as the great circle. So we're adding it back on top. It does also mean that we can still write a formula for that, right? So our formula, do we have this 2 pi r cubed divided, or 2/3 pi r cubed? Do we have that down somewhere? Okay. So I'm going to erase that. I'm glad we weren't waiting on Caleb. Okay. So we're going to get 4 pi r squared, okay, divided by 2 plus pi r squared. Okay, well, what's 4 pi r squared divided by 2 going to reduce to? So if I have 2 pi r squared plus pi r squared, what is that? 3 pi r squared. So if they ask me, hey, what is the surface area of a hemisphere, what can I add that to? Right? That would save me a whole lot of time. Okay, again, the book does not give you this formula. All right, I'm trying to give you stuff that is not in the book, okay, but will save you some time. So, I don't know. Those are Mr. Wilcox's personal sphere formulas, and they should work. All right, any questions over any of this? Okay. All right, so we're going to go from here. We're going to try to work out some problems. Hopefully everybody's got those formulas down. Let's see, geometry, lesson 80. All right, so we want to find the surface area of the sphere, both in terms of pi and as a number using 3.14. 4 pi, we want to round our answer to the nearest tenth. Okay, let's see. The first thing that we want to do here is notice that this red line goes all the way across. So is that a radius or a diameter? That is a diameter. So what am I going to need to do with that 17.6? I'm going to need to divide it by 2, right? All right, so what is 17.6 divided by 2? 8.8. All right, what was the surface area formula for a sphere?
4 pi r squared.
So 4 pi 8.8 squared. So the first case, we just want to solve it in terms of pi. So we're just going to take 8.8 and square it and then multiply that by 4. Can you tell me what that would come out to? 8.8 squared, right? 8.8 times 8.8 times 4.
309.76.
All right, let's take it to the nearest tenth. So 309.8 pi centimeters squared. So that's in terms of pi, right? Now let's go back. Let's do 4 times 3.14 times 8.8 squared. Tell me what I get just as a pure decimal. Caleb, you got a calculator or are you doing it on your Chromebook? 972 point what? 972.6. It just went to the nearest tenth centimeters squared. So our answer there comes out as A. Does that make sense? We understand what we're doing there? Okay. We only have about, what do we got, 11 questions? Okay. So we'll erase this. All right. Number 2. I might use some of this space that we got a nice big blank space up here. Find the volume of a sphere with a diameter of 9.6, both in terms of pi and as a number using 3.14 for pi. What number should show up in that statement as a red flag for me? Diameter, right? Diameter. So what needs to happen with 9.6? Okay, what's 9.6 divided by 2? 4.8. Okay, so we're going to use 4.8. And we're talking about volume. So what was the formula for volume of a sphere? All right, so we're going to use 4. We'll solve in terms of pi first. 4/3 pi r. So that's 4.8 cubed, not squared, divided by 3. So let's do this. Let's take 4.8 and cube it. Do we know how to do that? Do you know how to cube something in your calculator? Some of you do, some of you don't. Okay, let me show you how I would probably do this. Okay. Clear that out. 4 times 4.8, okay, to the third is one way we can do that. Divided by 3. I get 147.5. Yep. Well, I don't yet. 147.5 because it wanted it in terms of pi, right? Centimeters cubed. Now what I can do, though, is because I already have that there, is I can take that and multiply it by what? I can probably go ahead and multiply that by 3.14, and I'm going to get 463.0. 463.0 centimeters cubed. Okay, does that make sense? All right, my answer should come out here as A. All right, number 3 is one that has shown up on a number of tests. People really, really struggle with this question, so this is one you want to perk up, pay attention, and take good notes on. Notice that number 3 says that we know what the volume of a sphere is, but we want to find the diameter. Okay, so this is going to take place a little differently than a lot of questions that you saw. We know that volume equals 4/3 pi r cubed, or 4 pi r cubed divided by 3. But what can I substitute in for V in this question? 7,776. Anything else? 5. So we're saying 7,776 pi equals 4 pi r cubed divided by 3. All right. Now, can I solve for diameter directly? Can I go straight to diameter and solve diameter in this question? What am I going to end up solving for first? Radius. And then what am I going to do once I have radius? Multiply it by 2. How would you begin to solve for radius in this question? Divide. Okay, I got somebody who says divide. Divide by what? Divide by 4/3. Would that be this? Can I divide by a fraction? Multiply by the reciprocal. All right, so you're going to multiply by what then? 3 over what? 3/4. So multiply by 3/4. Okay, so what is 7,776 times 3/4? 4,000. 5,832. Is that what you said? Okay. So what do you have? 5,832 pi equals pi r cubed, right? You want to cube? Could I do something else first? Can I get rid of the pi's? Right? By dividing by pi on both sides? Is that going to cancel my pi's out? Yeah. If I divide by pi, Divide by pi. Pi's cancel because pi over pi is 1. So I'm really left with 5,832 equals r cubed. And he said to cube root it, right? What is the cube root of 5,832? Well, how do I even get my calculator to do that? Well, I go to math. I go down to number 4, 5,832, and I get 18, right? R equals 18, right? Okay, what was I needing to solve for, though? Okay, so my diameter equals what? No, what does my diameter equal? Not 9, 36, right? Because I need the diameter, which is twice, okay, twice my radius. Okay, so we should get D, 36 feet there. Now, you may see this exact question on a test. Does that mean that you'll get credit for it? No, you can't just memorize 36 feet. Okay? All right, you have to be able to show the work for that. So if you have questions, now's a good time to ask, or if you need me to go back to anything, I can do that. Okay? If not, we will move on. Okay, let's go down to number 4. Find the surface area of a sphere with a volume of 166.67 pi meters cubed. This is a lot like number 3, except it might even be a touch more difficult because I still need to solve for what here? How do I find surface area? What's the formula for surface area of a sphere? 4 pi r squared. So I really only need one thing in order to solve for surface area, right? I need to have the radius. Do I know what the radius of the sphere is? No. But because of what we did with question number 3, do I know how to find the radius? Okay? Tell me what to do, Brady.
166 equals 4 pi squared.
No. Volume.
4 pi r squared or cube.
Okay. Yes. All right. So we're going to solve for r, and then we're going to go back and plug it into my surface area, right? Okay. So what are you going to do first? Divide, multiply by 3/4 on both sides. Okay, 166.67 times 3/4. What do you think? Let's, I don't know what you might have done differently, but if I've got 166.67 times parentheses 3 divided by 4, okay? I get 125.0025. Is that what you got? Okay, you got that. All right, so my pi is going to cancel out. Okay, so what we're saying is that this equals r cubed. What do I want to do with 125.0025? Cube root it. Okay. Okay, this is approximately 125. Does anybody know what the cube root of 125 is? 5. R equals 5, as close as we can get it, right? Now, am I done? Now, what do I need to do? Find the surface area, right? So, surface area equals 4 pi 5 squared. What's 5 squared? What's 25 times 4? 100. All right, so we're saying that as close as we can get it, it's 100 pi meters squared. You follow me? Yes or no? Okay. All right, so we're seeing where they're giving us stuff, where they give us the answer, we have to plug and actually solve for a different part, okay, where we don't know the radius. Okay. All right, let's look at this. This one looks a little tricky, right? What's the relationship between the volume of the cone inscribed in a hemisphere and the volume of the hemisphere? All right. Well, a hemisphere, all right, let's look at this. Okay, what we have is we've got our formula here. We remember that the volume of a hemisphere was what? What was the volume of a hemisphere that I gave you? Okay. Does anybody remember what the volume of a cone is? Okay. 1/3 base times height. But it's a cone, so what is the base? What is it? What shape is the base of a cone? A circle. So how do I find the base of a cone? Circumference? Pi r squared. Okay, so you said it was pi r squared times height, right? Is that right? Okay. And you said it was divided by 3? Is that correct? All right. All right. So what I want you to see here is that this h is a radius, correct? Right? And this r is a radius. So could I substitute r for h? Yes or no? They should be the same, correct? Okay. So what happens when I make this an r? What's r squared times r? R cubed. So I can change this to, in this particular case, when a cone is inscribed inside a sphere, I'm getting pi r cubed over 3, and in a hemisphere it's 2 pi r cubed divided by 3. So what is the relationship? If this is basically 1/3 pi r cubed and this is 2/3 pi r cubed, how much bigger is 2/3 than 1/3? It's doubled. So what we're seeing is that our answer is B. The volume of the hemisphere is 2 times greater than the volume of the cone. Does that now make sense? Do we see we've got our math here to go with all that? Great. Okay, hopefully you guys connected with some of that. 6, what's the volume of a hemisphere with a 2-centimeter diameter? Again, what word should pop out there is a red flag. Diameter. Round our answer to the nearest of a cubic centimeter. All right, what was the volume of a hemisphere formula? All right, what am I using for r here? 1. Okay, what's 1 cubed? Just 1, right? Okay, so what's 2 times 1? 2. So it's just really 2/3 times pi, right? So what's 2/3 times pi? Or what is this? Anybody? 2.09 centimeters cubed. Okay, what time are you guys out of here? 48? Okay, I'll try to get through this. Okay, find the surface area in square meters of a hemisphere with an 11-meter diameter. What do I need to do with 11? Divide by 2. Let's call that 5.5. Okay, so we have, let's see, let's see. Surface area. What was our formula for surface area of a hemisphere?
3 pi r squared.
So 3 hemisphere. I gave them a different form. I gave them a formula for, but you were on the toilet. You missed out on some stuff. Huh? Oh, you said it. Okay, I'm sorry. Sorry to embarrass you in front of everybody for all time because of all the 5 people that are going to watch this YouTube video. I didn't even use your name, Caleb. All right. So 3 times 3.14, all right, times my pi, which is 5.5, or not my pi, but my radius. Let's see, and then we're squaring that, correct? So 3 times 3.14 times 5.5 squared. Somebody give me an answer here. 284 says to the nearest hundred, or let's see, what are we at here? All right, 284. I got 955, is that right? Meters squared. Okay, we're good there. 8. A spherical globe has a radius of 9 inches. What's the surface area of the globe to the nearest hundredth of a square inch? Okay, it says that's the radius, so I don't have to change any of that. We're looking for surface area. Well, this should be 4 pi r squared, right? All right, so that should be pretty easy to do. 4 pi 9 squared. What I would typically do with this is I'm going to leave pi out of it until I get to everything else multiplied. 9 squared is 81, correct? What's 81 times 4? What's that? 324. So I'm just going to do 324 pi. Okay? Anybody tell me what 324 pi is? Aaron, can you tell me what 324 pi is? $1,017.36 is what you got. Do you use 3.14? Okay, that's fine. If you end up using the symbol pi in your graphing calculator, you're going to get 88. It's not off by a lot, but it is different. All right. Okay. Ready for number 9. Number 9, find the surface area of a sphere with a 12-foot radius in terms of pi. I like it whenever they tell me to do in terms of pi because that's one less thing for me to do. Surface area of a sphere was 4 pi, in this case 12 squared, right? So 12 squared is 144. What's 144 times 4? 576 pi, because it's area, it is feet squared. 576 pi feet squared. We're good there? Okay. We've got just a few minutes. Let's try to get 10 done. Okay, find the volume of a sphere with a radius of 16 feet. That's going to be what? What's my formula? 4 pi, and so I got 16, not squared though, right? Because we're finding volume. Cubed, right? So you can do 16 cubed times 4/3 times 3.14 if you want to. Should be a fairly large number. Okay, help me out. Let's get this done. Give me the decimal. Nick, when you got it, let me know what it is. Seriously?
Yeah.
We're on number 10. All right, I'm going to have to ask somebody else because I don't want to chew up that time. Miss IL, when you got an answer for number 10? That is exactly right. Feet what? Feet cubed. 17,157.28 feet cubed.
17,148.
Did you use 3.14 or did you use the symbol pi? Okay.
So it's actually a pretty big difference.
The bigger the numbers you're working with, the bigger difference it's going to become. Okay. If you're working with relatively small numbers like 1, 2, 3, even 10s, 12s, where you start to get to hundreds or thousands, right? That the difference between pi and 3.14 gets a lot bigger. Okay. 11, find the surface area and volume of a hemisphere with an 8-inch diameter. So the first thing we need to do is what? So we have a 4-inch radius. Okay. Surface area of a hemisphere is what? 3 pi r squared. So we're going to do 3 pi 4 squared. 4 squared is 16. What's 16 times 3? 48. What's 48 times pi? Okay, so let's call it 150.8. Okay, so it's 158.8 inches squared. That's surface area. Volume was what? 2/3 pi r cubed. So 2 pi r, in our case, r is 4, right? Divided by 3. So 3 cubed is what? Is that 64? 4 cubed is 64, so it's 64 times 2. Is that 128? What's 128 divided by 3? Okay, multiply that by 3.14. 134, probably around 0.04, something like that. Okay, 0.04 inches cubed. Okay, that's our volume. All right, do we think that we understand? At least we have those 4 formulas down. We go back and use them. Be careful, they might give you the solution and ask for the radius. Okay, know how to do that, know how to find diameter. Okay, go back and rewatch some of this if you need to.